Let's continue with dealing with logarithm functions. We're going to solve some equations this time. Actually, consider this not solving as much as it is evaluating. Just know that in the end, you end up doing some solving to do the evaluation. So without further ado, let's take a look at this. In the first one, we're going to take our base, 216, and we're going to rewrite it into its exponential form. So then we can use that to be able to do some solving. All right, let's try that again. So 216 to the x is equal to 6. Now there's a couple ways you can look at this. Like you can take your calculator and you can start messing with exponents of 216 to try to get it to get down to look like 6. Or you can recognize, which probably is going to happen a lot, but it's something to investigate, looking at 216 as a possible power of 200 or a power of 6. So 216, like 6 to what power would give you 216? So really, in essence, it's kind of the same thing. But if you look further into this, you can actually see that if you do some math here, 6 times 6 times 6 will give you 216. That means that 216 to the x can be rewritten as 6 to the 3 times that x equal to 6. And then in our previous chapter, we saw that if your bases are the same, you could set the exponents equal to one another, finding out then that x is going to be equal to, in this case, 1/3. So what does this mean? It means that x is 1/3, so log, if I look back at this original, base 216 of 6, that would be the same as 1/3. Okay, so when they ask you to evaluate, they're really wanting, well, what's the value for x that makes this true? Let's clear some space and look at our next example. I would encourage you to pause the video at this point and rewrite b into its exponential form to see how you might go about solving it. All right, so welcome back. Hopefully you took some time to write that x to the third would be equal to 12. Now this time, and by the way, you're not going to see these examples in the book. I believe there's probably some homework that's going to go along these lines. So oh, a little deeper look here. They don't necessarily do it this way. So you'll see something like this later on in your experience. I'm just going to go ahead and continue with it anyway. So we would end up taking what, the third root of both sides to solve that, giving us that x is going to be approximately, and if you take the third root of 12, what does that give us? About 2.29. So what's that mean? That means the log base 2.29 of 12 would equal 3. All right, and then the last one, C, we would take our 9 to the 1/2 power is equal to x. Well, the half power of 9 is the same thing as square root of 9. That means that that would be 3. So in this case, x would equal 3. That means this, log base 9 of 3 equals 1/2. Yeah, we've seen something like that before if you paid attention to the videos. So that's your way of finding any value within a logarithm expression, finding a missing value within that, either the base or the log itself, or the number you're taking the logarithm of. All can be found using this evaluation method. All right, see you guys in the next video.